Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad HAZAMI from JCDCS 143 So today I want to present about application of linear algebra in transportation. So this is a collaboration with our groups. So there are my group's member, which is FARAH FAZURINA, QAISARAH, and HAKIM.
Let me begin by introducing Cramer's rule, which is a fundamental concept in linear algebra. Cramer's rule is a method used to solve a system of linear equation using determinants. However, this method is only applicable when the system has the same number of equations as unknowns or variables. There are two main conditions for using Cramer's rule. First, the coefficient matrix must be a square matrix, meaning that it has an equal number of rows and columns. Second, the determinant of the coefficient matrix must not be zero, because a zero determinant means the system doesn't have an unique solution. On the right side of the slide, we can see a visual representation. The solution for each variable is expressed in terms of determinants. Each variable's determinant is calculated by replacing one column of the coefficient matrix with the constant matrix, while keeping the other columns the same. This rule allows us to solve for each variable such as x, y, and z individually. So now, let's move on to the purpose of our study. Our main objective is to apply linear algebra to a real-world problem, specifically in the transportation sector, focusing on fuel consumption. Here are the specific goals we aim to achieve. First, to apply linear algebra in analyzing fuel consumption for each type of vehicle. Then, to form an augmented matrix for our system of linear equation. We will use cofactor expansion to find the determinant of the system. Next, we will solve the system of linear equation using Cramer's rule. This study will help us understand the real-life advantages of using matrices. Finally, we aim to calculate the fuel used per trip for different types of vehicle. Overall, this study bridges mathematical concepts with practical applications in transportation and efficiency.
So there is the formula of Cramer's rule, which is x1, x2, and x3. So each x we need to divide a1 divided by a, which is, for example, a1 we need to replace the column 1 in matrix A with B. And for the x2 and x3, it's the same thing that you can do, you need to do, which is you need to replace column 2 in matrix A with B. And another x3, we need to replace the column 3 in matrix A with B.
A problem statement given that a logistic manager is trying to determine the fuel efficiency in miles per gallon of three different types of delivery vehicles, a truck, a car, and a motorcycle. However, the exact efficiencies are not recorded, but the manager has data on fuel used for mixed trip involving combination of these vehicles. From the records of three different delivery days, it shows that day 1, 1 truck, 2 car, and 3 motorcycles used a total of 36 gallons of fuel. The second day, 2 truck, 1 car, and 2 motorcycles used a total of 33 gallons. The third day, 2 truck, 3 cars, and 4 motorcycles used 56 gallons. From this slide, it shows that 3 records from 3 different delivery days. So, in the left side, record 1, we have 1 truck, 2 car, and 3 motorcycles have a 36 gallon of fuel. And in the middle, record 2, 2 truck, 1 car, and 2 motorcycles use 33 gallons of fuel. So on the right side, we have a record 3. It shows that 2 truck, 3 car, and 4 motorcycles use a 56 gallon of fuel.
Now, let's move on to the solution for this problem. Before that, we need to take out the important information in order to solve the problem given. From the problem statement, we get all the record from the 3 different delivery days, starting from record 1, which are 1 truck, 2 cars, and 3 motorcycles, which use about 36 gallons of fuel. For record 2, they have 2 trucks, 1 car, and 2 motorcycles, which use around 33 gallons of fuel. And finally, for record 3, they have 2 trucks, 3 cars, and 4 motorcycles, which use about 56 gallons of fuel. And here, we need to find the fuel efficiency in miles per gallon for this different type of delivery vehicle. So, now, we move on to the calculation to solve for this problem statement. Step 1. We need to collect and substitute each vehicle as a variable. Here, we let x equals to lorry, y equal to car, and z equal to motorcycle. Second, we need to form a linear equation based on the problem statement given. Here, we get x plus 2y plus 3z equal to 36. 2x plus y plus 2z equals to 33. And finally, 2x plus 3y plus 4z equals to 56. Next, we use the Cramer's rule to obtain the value of x, y, and z. Now, everyone knows how to use the Cramer's rule just now, right? So, let's follow this step. Step 1. From a linear equation, we need to write in the matrix form, which is ax equals to b. A is the coefficient of the matrix, while x is the variable of the matrix, like x, y, and z we just did earlier on. And b is the constant matrix. And then, it will be like this. Step 2. We need to compute the determinants a, ax, ay, aaz respectively. To find the determinants, we use the formula cofactor matrix. The calculation is, use along row 1 and we get a equals to determinant 1, 2, 3, 2, 1, 2, 2, 3, 4. Now, using cofactor matrix, we can get 1 times determinant 1, 2, 3, 4 minus 2 times the determinant 2, 2, 2, 4 plus 3 times determinant 2, 1, 2, 3. After we get those determinant equation, we can calculate the whole sum of it, and then finally we can get the answer is 2. Now, after we obtain the determinant value for matrix A, we move on to calculating the determinant for each of the corresponding matrix, which are ax, ay, and az. Here, we use the same way as we calculate the determinant of A. However, for each ax, ay, az, we need to change each column to the constant matrix according to the matrix respectively. For instance, in matrix AX, we need to change the column 1 with constant matrix. After that, we calculate its determinant by using along columns 2. And we get AX equals to 17. Next, we need to complete for another 2 determinants, which are AY and AZ. Just like previously, we need to change the column with constant matrix, but now, we change AY in column 2 and AZ in column 3. And then, we calculate both of the determinant by using along column 1. And we get for AY equals to 14 and AZ equal to 9. After we obtain determinant, now we need to calculate this result, which will be represented by the next presenter.
Now I'm gonna explain the step 3. Find the value of the variable x, y, and z when a not equal to 0 using formula simplify divided. So we have here the formula s equal to determinant ax over determinant of a. So we substitute the value that we get from the previous presenter. We get 17 over 2. So the used gallon of fuel of truck is 17 over 2. Next we're gonna find the use of gallon of y, which is for the car. So we have the formula here, y equal to determinant ay over determinant of a. So we substitute the value, we can get 14 over 2. So we simplify the fraction, we got 7. So the used gallon of fuel of the car is 7. Next we're gonna find the value of z. So we have the formula here, z equal to determinant az over determinant of a. We substitute the value, we got 9 over 2. So the used gallon of fuel of the motorcycle is 9 over 2.
So the conclusion is, Cramer's rule is a mathematical method used to solve system of linear equations of the same number of equations as unknowns, using determinants. It only works when the number of equations match the number of unknowns and the determinants of coefficient matrix is not 0.